Hey everybody, I apologize, but I accidentally ended the last video when I did not intend to. So I'm going to continue where we left off. So we were talking about example 2. Is the conclusion valid or invalid? If it's valid, what type of reasoning is used? So we had the statement, if two angles form a linear pair, then they are supplementary. Okay, that is true based on one of the theorems that we had earlier in the notes. If two angles are supplementary, then they have a sum of 180 degrees. That is true because it's the definition of supplementary angles. And we're putting that together to create the conclusion, if two angles form a linear pair, then they have a sum of 180 degrees. That is a valid conclusion. We are using deductive reasoning. More specifically, it is the law of syllogism, where if P implies Q and Q implies R, then P implies R. So that's your P, that's your Q. So you've got Q, R, this becomes P, R. And it's that whole workings of how the law of syllogism works. Now, in example 3, we have the same question. Is the conclusion valid or invalid? If it's valid, what type of reasoning is used? So we have a statement, if two angles form a linear pair, then they are supplementary. Same theorem we used before. If two angles are supplementary, then they have a sum of 180 degrees. The conclusion, if two angles have a sum of 180 degrees, then they are a linear pair. In this case, it's very similar to the previous example, except if we look at this statement right here as being our P, this statement as our Q, so we have our Q, and this statement as our R. This says if R, then P basically, which does not follow the law of syllogism. We can't just change that order and expect it to always be true. So this conclusion is actually going to be invalid. All right. Now, it doesn't ask for this, but you could give a counterexample to show that it's not true. You know, counterexamples are one example showing that some statement is false. So if two angles have a sum of 180 degrees, well, I could have this angle that's 30 degrees. I could have this other angle that's 150 degrees. Well, those have a sum of 180 degrees. Then they are a linear pair. Those are not a linear pair. They're not two adjacent angles that have that sum of 180 degrees. So again, you've got to be careful as you read these and make sure that the statements always work, that they're always true. So we had an invalid conclusion in this situation. All right, the next thing we're going to look at, guys, is that we're going to look at algebraic proofs. An algebraic proof is just, it's a proof made up of a series of algebraic statements. Okay. So an algebraic proof is a proof that is made up of algebraic statements. And this is something that you guys may have done in an algebra class. Possibly, possibly not. So there's some properties that we have to know when we do algebraic proofs. There's something called the addition property of equality. And basically what the addition property of equality says is if A is equal to B, then A plus C is equal to B plus C. Meaning we can add the same thing on both sides of the equation and still get a true equation. The subtraction property of equality, if A equals B, then A minus C is going to equal B minus C. Again, we're subtracting the same thing from both sides of that equation. The multiplication property of equality, you could probably guess what that is at this point, but if A is equal to B, then A times C is equal to B times C. We have the division property of equality, which would fall under if A is equal to B, then A divided by C is going to equal B divided by C. Okay. And again, it's just that idea that you can add the same thing on both sides of an equation, you can subtract the same thing on both sides of an equation, multiply both sides of an equation, or divide both sides of an equation by the same thing, and you still get an equation that's true. All right? We have some other properties, the distributive property. So the distributive property basically says if we have A times B plus C, that is going to equal A times B plus A times C. All right? There is a transitive property that says if A equals B and B equals C, then A equals C. Because you have two values, A and C, that are both equal to the same value, B. That's called the transitive property. It might look familiar because it's very similar to the law of syllogism. There's a symmetric property that says if A is equal to B, then B is equal to A. Just basically saying you can switch the sides that the terms are on as long as you do both sides. Okay? And then the reflexive property basically just says that A is equal to A. Okay? Any value is always going to be equal to itself, and we refer to that as the reflexive property. One of the other statements that might come into play is combining like terms. So there are going to be times when the step will be to simplify by combining like terms. And those are generally the properties you're going to use in an algebraic proof. So let's go through a couple examples. We're given this equation, 5x plus 1 divided by 2 minus 8 is equal to 0. And we're going to try to prove that x is equal to 3. So in this proof, we're going to do what's called a two-column proof. So you make this T, statements are going to go on the left, reasons are going to go on the right. In the first statement, I'm going to write the equation that we were given. 5x plus 1 divided by 2 minus 8 equals 0. The reason that we know that that's true is because it's given to us. So our first reason should always be given. Now, in the next step, think about what you would do to solve this equation algebraically. Most people are going to add 8 to both sides. So we have 5x plus 1 divided by 2 is equal to 8. So we're adding 8 on both sides. We can do that because of the addition property of equality, which allows us to add the same thing on both sides of an equation. The next step in solving this equation would be to multiply both sides by 2. So when you multiply the left side by 2, you get 5x plus 1. And when you multiply the right side by 2, you get 16. That is the multiplication property of equality. Next, you can subtract 1 on both sides. So 5x is equal to 15. Again, we subtracted 1 from both sides. We can do that because of the subtraction property of equality. And the final step to isolate x would be to divide both sides by 5. 15 divided by 5 is 3. Again, because we divided, that's the division property of equality. So your reasons are really just explaining what you were doing and why you're able to do that. We started with the original equation, that is our given. We're going to be done with the proof when we reach the statement that we are trying to prove, which was the solution x equals 3. All right, in the next example, we got one more. We've got 6x plus 3 on the left side, and that is equal to 9 times the quantity x minus 1. We know that's true because it is given to us. Now, when solving equations, typically you want to simplify each side of the equation first. So we're going to leave the 6x plus 3 alone, but on the right-hand side, we have to distribute 9. So we got 9x minus 9. And we can do that because of the distributive property of equality. From there, you know, people might take this in a different step. We want to end up with x equal to 4. So I'm going to move my x's to the left side of this equation. And I'm going to do that by subtracting 9x on both sides. 6x minus 9x is going to be negative 3x. And then 9x minus 9x, they cancel, so I'm left with negative 9 on the right side. Again, I subtracted 9x from both sides. That is the subtraction property of equality, which you could just abbreviate as POE, okay? Property of equality. For number 4, we're still working on getting x alone. We're going to add or take care of this plus 3, and we're going to subtract 3 on both sides. Negative 9 minus 3 is negative 12. Again, we subtracted, so that's the subtraction property of equality again. The fifth step, we'll get x alone. We're going to divide both sides by negative 3. That'll give me x on the left side, and negative 12 divided by negative 3 is a positive 4, because negative divided by negative is always positive. We divided, so that is the division property of equality. And that is how you are doing an algebraic proof. All right, you're essentially solving the algebraic equation, but you're providing a reason for each step along the way. All right, guys, hope you found the video useful. If you need to, watch it again, and I will see you next time.